Welcome back. Section 7-3, Trigonometric Substitution. Here we learn about using trigonometric substitutions. For example, here is example 1. Evaluate integral square root of 4 minus x squared dx. Substitute x equals 2 sine theta. Where did that 2 come from? Comes from 4. You will see in a minute. X equals 2 sine theta for theta between negative pi by 2 and pi by 2. So dx is 2 cosine theta d theta. Alright. So 4 minus x squared is 4 minus 2 sine theta squared. So squaring it, that gives you a 4. That's why, remember I said this 4 reduces to 2 because you are going to square it and get a 4 back. 4 minus 4 sine square theta. Get 4 common, you have 1 minus sine square theta inside. 1 minus sine square theta is nothing but cosine square theta. So 4 minus x squared is 4 cosine square theta. So square root of 4 minus x squared is square root of 4 cosine square theta, that is 2 absolute value cosine theta. Now this is where you need the limits for theta. Theta being between negative pi by 2 to pi by 2 tells you that absolute value cosine theta is same as cosine theta because cosine theta is greater or equal 0 in this particular domain. So coming back to our original integral square root 4 minus x squared dx is integral, we just calculated square root 4 minus x squared is 2 cosine theta. Dx we just saw was 2 cosine theta d theta. So in all this is 4 integral cosine squared theta d theta. Cosine squared is nothing but cosine 2 theta plus 1 over 2 d theta. Taking integration, so notice 2 reduces that 4. 2 integral cosine 2 theta plus 1 d theta. Integral of cosine 2 theta is sine 2 theta over 2. Integral of 1 is theta, there's a 2 outside. So distributing, that reduces, you have sine 2 theta, this becomes 2 theta plus a constant. Sine 2 theta is nothing but 2 sine theta cosine theta plus 2 theta. Now why did we do all this? We did all this because our question was in terms of x. You already know what sine and cosine are, right? So sine theta is x over 2. Cosine theta is here. Cosine theta is going to be square root 4 minus x squared over 2. Alright. So 2 sine theta is x over 2. Cosine theta is root 4 minus x squared over 2. So overall f4 here, but that 2 reduces. And 2 theta. What is theta? Theta is sine inverse of x over 2. What is theta? You divide by 2, take arc sine, and that's what is theta. Alright, plus constant. So you found the integral in terms of x. So here are the table of trigonometric substitutions. When you have square root of a squared minus x squared, a being some particular constant, fixed constant, like in our case 4, right? Square root of a squared minus x squared, substitution should be x equals a sine theta. Square root of a squared plus x squared, so if you have a plus, then x should be a tan theta. Square root of x squared minus a squared, that is x comes first, then x should be a secant theta. So these are different domains for your thetas for the functions to be properly defined. Okay, so remember constant minus x squared sine, constant plus x squared tan, x squared first, then a constant x squared minus a squared secant. Here is a second example. Evaluate integral square root 16 minus x squared over x squared. So constant minus. So that tells me some kind of sign. Take the square root of 16, that's 4. So x equals 4 sine theta for the given domain. Dx therefore will be 4 cosine theta d theta. What about 16 minus x squared? 16 minus x squared is 16 minus 4 sine theta squared. 16 minus 16 sine squared theta. 16 common 1 minus sine squared is cosine squared. So that square root will apply. Okay. So you have here x squared is 16 sine theta squared. Numerator is 16 square root of 16 cosine squared theta. And dx itself is 4 cosine theta d theta. So upon simplification, numerator becomes 4 cosine theta, denominator becomes 16 sine squared theta, and you have one more multiple, 4 cosine theta. Simplifying, 4 times 4 is 16, over 16, the constant goes away, cosine squared over sine squared. Cosine squared over sine squared is cotangent squared. Cotan squared is nothing but cosecant squared minus 1. Integral of cosecant squared is minus cotan. Integral of 1 is theta. Don't forget constant of integration. So once we have this, you can think of cotan as 4 cosine over 4 sine. 4 cosine is square root 16 minus x squared. 4 sine is x. That was our initial substitution, right? So you are able to write down what cotan is. It's a negative square root 16 minus x squared over x. That's here. Minus theta. How do I get theta? Well, divide both sides by 4. So x over 4 and then sine inverse. So theta is sine inverse of x over 4 plus that constant of integral. Now here is the